Let me know when you're ready. Okay. Okay, everybody, welcome to our first face-to-face meeting of Stat 151 for the semester. This is something that I am adding this semester to the online course because I felt like it was something that was really kind of lacking last semester. I felt that people would really benefit from a chance to meet their classmates, work through some problems maybe, ask questions without having to, come to office hours, having something that's more sort of built into your schedule to come and ask questions. So hopefully this will be helpful. What I was going to do today is I have a few questions that I had picked up either from the discussion board, or there was a couple of homework questions from last week that as Nate graded, he said there were a lot of people who had trouble with a couple of the questions. So I was going to go over those and then answer any other specific questions that you guys have either about the material or about problems that you're working through for this week or any of the stuff from last week, whatever you want. I'll do my best to sort of answer off the cuff, okay? So that said, I am going to start by taking a look at the homework from last week. Last week, if you remember, focused on defining what we mean by an outcome space, which is just the set of all of the possible outcomes of a random experiment. And then also a bit about using set notation. So here's the homework from last week. A couple of things just to think about with set notation. When we talk about an event, say we have two events, A and B, if we talk about A or B happening, we use the union notation is our or. If we talk about both events happening, we use the intersection. That's our and. Right? So kind of keeping in mind that union is an or situation, either one of the events or the other or both occur, and the intersection means that both have to occur. So A and B both occur. Okay, so for this one, we're looking at, there were 11 students registered for an introductory statistics class. For each student, the professor is interested in knowing what type of degree they're pursuing, undergraduate, graduate, or non-degree, and whether or not the student has taken a statistics class at some time in the past, yes or no. So we had all the outcomes were going to be some sort of a pair. For each individual student, they are going to have a degree associated with them and whether or not they had statistics associated with them. Now, to set this up as a Venn diagram, what we had is we had the possibilities were that we had an undergraduate who had taken statistics before. We had undergraduates who had not taken statistics before. I think I have to write bigger or zoom in. So I'm going to zoom in since I already started writing. There we go. We have graduate students who took statistics before and graduate students who did not take statistics before. And then we have non-degree students who took statistics before and non-degree students who did not take statistics before. So those were our possible outcomes in the sample space. So our sample space S was the set of all of these 6 outcomes. Whoop, I'm off the side. There we go. So when we drew the Venn diagram, what we want to do is we want to represent the entire sample space with those events, where A is the event that the person is pursuing a degree, and B is that they have taken statistics before. So when we think of events, when we work with probability, events are a set. They're a set of outcomes from the sample space. So the set of these outcomes that correspond to pursuing a degree, well, if they're pursuing an undergraduate degree or a graduate degree, they're included in that event A. So event A is the undergraduates who have not taken statistics, the undergraduates who have taken statistics, the graduate students who have not taken statistics, and the graduate students who have taken statistics. That's event A. Now, event B is all the students, going to include all the outcomes that include having taken statistics before. So those are going to be these: the undergraduate, graduate, and non-degree students who've taken statistics before. So B and A have some overlap. These two outcomes are in both. So there's the overlap. And the other outcome that's also in B but not in A is here where we have the non-degree students who've taken statistics before. And that's all of the outcomes in our sample space except one. We have the students who haven't taken statistics before and are non-degree students, which are outside of both of those events. So there's our sample space S. So if we want to reflect it with a Venn diagram, that's how we can do it. Okay, so the question, one of the question that seemed to be the most problematic was this question 10, which asked, which of the following indicates that a student has not taken statistics and is not pursuing a degree, right? So we use the complement, means that an event A means that A has not occurred. So if we want to look at people who are not pursuing a degree and A is pursuing a degree, then A complement means that they're not pursuing a degree. Similarly, if we have people, B is the event that a person has taken statistics. If they have not taken statistics, they would fall into the complement of that event. B complement is no, not taken statistics. Right. So if we have someone who is not pursuing a degree and has not taken statistics, right? We have, they're in the complement of A and the complement of B. When we use the and, is that a union or an intersection?
Intersection?
Yeah, that's our intersection. So we could write this event as A complement intersect B complement. So that's this answer. Now, if we look at the A complement intersect B complement, A complement is everything that's not in A. B complement is everything that's not in B. We can see that the overlap is here with the people who are non-degree and not pursuing and have not taken statistics before. The other way we can express that equivalently, if we have A union B prime, what this means is that it's not in either A or B, right? Because A union B would be, that would mean that either the person is pursuing a degree or they have not taken statistics. So if that's true, then this would be they are not pursuing a degree or taken statistics. And that is actually equivalent to that same event. So there are two different ways of expressing that. If we look at the complement of A intersect B, here's A intersect B. The complement would be everything else. So we can see that that does not, that would include people who are pursuing degrees but have not taken statistics. It would also include people who are non-degree who have taken statistics. So that's not the same thing. So it was one of the common mistakes was to choose this answer, which is actually not correct. Yes?
Oh, nothing.
You sure?
Yeah. Actually, I had this right, and I got a point deducted saying that it's wrong.
Okay, well,
I had to figure out why.
all right, why don't we take a look at it afterwards in terms of when Nate went through and graded it, it's entirely possible he
said
could have...
union instead of the intersection. He said the first one.
Okay, well, I'll take a look at it. We'll have to take a look at it when, you know, if there are questions about individual grading, I'll look at those after, and we can always fix them. Sometimes everybody makes mistakes. Probably Nate just made a mistake when he graded it. Okay. Were there any other questions from the homework last week that anybody wanted to look at specifically? Okay, so I'll take a look at that for you afterwards, Sabrina. Check number 10. So I'll just check number 10 on your homework. And I'll look through them all, that question 10, and just make sure that that mistake wasn't something that he carried over. Yeah. Okay. Okay, before I start with the question from the discussion board, does anybody have any specific questions that you want to talk about today, or any topics that you want some more discussion of? Anything in particular? Okay, so I was going to look at, there was question 1.1-12. Let me find it here. So we'll just take a look at it first. Whoa, it's still zooming. Okay. So 1.1-12 is looking at the situation where you say, okay, we want x to be a number that's selected randomly from the closed interval between 0 and 1. So we've got an interval from 0 and 1, and we're going to randomly select some number along that interval. Could be anywhere along there. And we want to use intuition to try to assign probabilities. So let me move that up a little bit. Okay, so we're going to randomly select a number somewhere along here. Now, just in terms of thinking about it, if we know that the number is going to be between 0 and 1 that's selected, right? We know that's true. Then what's the probability that the number we select will be somewhere between 0 and 1?
100%.
1, right? It's going to be, or it's going to be 100% 1, right? So the probability that we select x so that x is between 0 and 1 is equal to 1. And this is asking us to work with just intuition, right? It's not asking us to do for any sort of, I mean, you could get very involved with measure theory and doing very rigorous calculations and with this kind of problem. But it's just asking us to think about this intuitively. So if we want to know then the probability that we randomly select a number, x, that is between, say, 1/4 and 3/4. What do you think the chance is that we'd get a number in that range? We're randomly selecting something that's equally likely to be anywhere between 0 and 1. What do you think, just intuitively, what do you think the chance is that it's going to fall in there?
50%.
What's that? Half, 50%, right? Because that's half the distance, right? That interval from 1/4 to 3/4 is half the length of the interval from 0 to 1. So we think, okay, well, it makes sense. It should be about half, right? So intuitively, we can say, well, this should be 0.5 or 1/2, right? And we can think of this probability of our value falling in any particular interval as being related to the length of the interval, right? So if we think about it that way, what's the probability that we select the number x and x happens to be exactly equal to 1/3? So now we're between 0 and 1. Here's 1/3. What do you think the chances that we land exactly, randomly pick any number anywhere along that interval, and we land exactly on 1/3?
0.
Okay. But could we land on 1/3? It's possible it could be 1/3, right? So this is something that is often very confusing at the beginning of this course. And it's something that I saw on the discussion board this time. This is the 3rd time I've taught this course online, and it always comes up in the discussion board. This idea that, you know, people look at it and they say, okay, well, if I think about this either as looking at sort of, okay, well, what's the chance? Well, it's one number out of an infinite number, so I can think of it sort of that way as like, well, it's got to be 0, you know, or the length of the interval. Well, at one point, there's no length, so 0, right? But then people get bogged down in the fact that, but something's got to happen, right? And a lot of times we learn, especially in sort of more introductory statistics courses, that having a probability of 0 means that something will not occur. And this is something that is only true if you have a countable number of possible outcomes, right? If you have, you know, if I said, well, I've got 4 possible outcomes and the probability of one of them is 0. Well, that would mean that that's not going to happen, right? But if I have a continuous interval like this with an uncountable number of possible outcomes, then the probability that any one individual outcome is going to occur, that I'm going to have exactly 1/3, is 0, even though it could happen. So this idea that, you know, 0 probability does not always mean that something can't happen, and that you can have an event occur that had 0 probability. And this is something, as I say, it's something that is often a little counterintuitive at the beginning of this class. It's something that we'll see again as we move into continuous random variables. We're going to sort of work through the course. We start off by learning sort of the definition of probability. Next, we're going to learn some counting techniques to use. We're going to learn some more topics about independence and conditional probability. Then we'll move on to looking at distributions of random variables. We'll start with discrete random variables, where we have a countable number of possible outcomes. And then we'll move into continuous random variables. And when we do, we'll come back to this idea that the probability of any one exact outcome is 0 when we have sort of a continuous group of possible outcomes, which is what we have here with this interval. All right. Any questions or comments about that? And I posted a link on the discussion board to an online article that kind of talks a little bit about that. I think it's kind of a good one. It's very sort of intuitive. It's not too heavy in the measure theory, which some of them are. Talk about this. Okay. All right. Are there other things that people want to go over? Whoops. Okay, so I've got one more thing that I'll talk about then that I think might be helpful with the homework. So later on, when we get into the part of the course where we are looking at conditional probability and independence, we're going to learn a multiplication rule, which some of you may have seen in Stat 141 or other courses, where we learn how to calculate the probability of an intersection using a multiplication rule. But we haven't learned that yet in this class. So if you've seen multiplication rule kind of stuff before, you have to, for this week, kind of pretend that you don't know anything about that. We're asked to work with intersection on the homework, we need to think about the fact that the only way that we've really learned to work with intersections so far is either with sort of figuring out the possible outcomes in the outcome space and looking at the outcomes that fall into both groups. But the other way that we can look at it is by keeping in mind that we learned about the union, the probability of A union B, the probability that event A and event B both occur is equal to, let me move this out of the way so I can put this where I can see it, the probability of A plus the probability of B minus the probability that both A and B occur. Right. And if we think about this in terms of our Venn diagram, this kind of makes sense. If I look at everything in A and everything in B, I've counted this middle part twice, the intersection. So I need to subtract off the probability of the intersection if I add those two probabilities together. So if we want to calculate the probability of the intersection for this week, we need to think about doing it using the union and the two events. So what this means is that the probability of A intersect B is equal to the probability of A plus the probability of B minus the probability of the union. Right? Just manipulating that a bit. So as long as we know the probability of A and B and the union, we could calculate the intersection. Right? So for instance, if I knew that the proportion of people who like chocolate ice cream is 0.7, and the proportion of people who like vanilla ice cream is 0.6, and the probability that a person likes, that was not written correctly, probability of vanilla is 0.6. The probability that a person will like both chocolate and vanilla, will like either chocolate or vanilla, is 0.9. Then I can figure out what proportion of people, what probability is there that a person likes both chocolate and vanilla. Probability of chocolate and vanilla. This is my intersection. This is my union. I can take the two individual probabilities, probability of chocolate plus the probability of vanilla, subtract off the probability of the union, that gives me 0.13 minus 0.9 is 0.4. So just in terms of working with finding intersection, when we haven't done that multiplication rule yet, we need to think in terms of working with these types of unions, the relationship between the union and the intersection to find it. Okay, so I guess the last thing, I mean, we still have quite a bit of time left, but if you don't have questions that you want to ask, the other thing I would just be interested in is getting some feedback from you guys. We don't necessarily need to do it on recording right now, but to get some feedback from you in terms of what you'd like to do during this time. I can always come up here and talk about some of the homework. I can give some tips for the new homework. I can, you know, talk about things that come up on the discussion board. But if there are other things that you'd like to do, like have me bring some extra problems that aren't part of the homework to work on and then go over, if you want to try to share some solutions that you've been working on, those kinds of things, if you can just let me know what you guys think would be the best use of this time for you. You know, that's what I'm here for, not just to put myself on tape. So please just let me know what you guys want to do with this time. I want it to be the most productive time it can be so that you get the most you possibly can out of the course. Okay? So we can end the recording at this point, and if you